In fields across the world, strange designs appear overnight too perfect, too vast, too mathematically precise for a casual prank. Some claim it's art, others call it a hoax. Yet researchers studying geometry, plant biology, and coded messages say one thing keeps surfacing: not all of it adds up. Could these circles really carry a message? Some appear to encode universal constants, star maps, even warnings. If the patterns are not ours, then whose are they? Today, we dig into the mystery that the world tried to dismiss. The Tully saucer nest. Every great mystery has an origin story, and when it comes to crop circles, many people assume it all began with pranksters and planks in the English countryside during the 1970s and 80s. But the record tells a different tale. Long before the word crop circle hit headlines, a farmer in Queensland, Australia, stumbled upon something that still unsettles researchers today. On January 19, 1966, George Pedley was driving his tractor across Horseshoe Lagoon near the town of Tully. It was a clear morning until a strange hissing sound broke the silence. Startled, he looked up and saw something he would never forget: a metallic disc rising from the reeds. Within seconds, the object shot skyward, leaving behind a swirling disturbance. When Pedley inspected the spot, he found a circle nearly 30 feet across pressed into the reeds, every stalk bent into a clockwise spiral but not broken. The plants lay smooth and intact, as though gently molded into place by a force he couldn't see. This wasn't just a farmer's tale. Pedley immediately reported the incident, and within days, the Royal Australian Air Force launched an official investigation. Their records, which were declassified years later, show the site was carefully mapped, measured, and photographed. Investigators noted the precision of the formation: a perfect ring, no footprints, no machinery tracks, no signs of fire or chemical damage. The reeds were bent at their nodes, not crushed, just as later researchers would document in European circles decades later. Locals called it a saucer nest, a term used for similar circles reported in wetlands during the rainy season. Yet none had ever been seen forming until Pedley's account. That first-hand witness testimony paired with physical evidence and government documentation made the Tully case stand out. Unlike the hoaxes that would later dominate headlines, this was not a prank confessed years after the fact. It was an official, contemporary report backed by multiple forms of evidence. The remaining factors somehow made the Tully nest all the more interesting. The features themselves were reminiscent of those later observed in unexplained crop circles: clockwise swirls, bent but unbroken stems, sharp edges where the effect suddenly stopped at the circle's periphery. Such uniformities imply that it is an adventitious phenomenon operating with calculatedness and not random weather or human-induced trickery. There may be skeptics claiming whirlwinds or waterspouts have crafted such a nest, but no unusual conditions regarding winds have been established by meteorologists after checking the data at the time. The reeds do not, as storms often do, leave behind an arbitrary scatter, but neatly spiral. This kind of thing disturbs researchers. It's as if something can selectively act on the plant. In the months that followed Pedley's report, similar nests were seen in nearby locations in Queensland and New South Wales. Each of them was characterized by the same signature traits: stems bent at the nodes, no footprints, and mathematically perfect circles. This phenomenon had been recorded years before the cultural craze for crop circles, regardless of whether some unexplained natural force or less ordinary phenomenon was behind it. The Tully case became, decades later, a litmus test for investigators like Colin Andrews, proof that not every circle could be put down to human troublemaking. Then it established a scientific benchmark for what a genuine unexplained formation might look like. The reeds of Horseshoe Lagoon were more than just flattened plants, they were the first pages in a mystery still unfolding. If formations like the Tully nest predate the pranksters, then what do we make of the circles that appear to encode advanced mathematics patterns too complex for chance? Geometry in the fields. By the late 1980s, crop circles had spread isolated rings. Fields in southern England began to display shapes that looked less like accidents and more like blueprints. What caught researchers' attention wasn't just the beauty of the designs but the mathematics hiding inside them. One of the first to treat the circles as more than curiosities was Dr. Gerald Hawkins, an astronomer and former chairman of the astronomy department at Boston University. Hawkins wasn't interested in UFOs or folklore, he focused on ratios, measurements, and geometry. He pored over aerial photographs and field surveys, measuring the diameters and distances between circles. What he found startled even skeptics. The formations weren't random. The ratios of circle sizes and spacings are lined up with the diatonic scale, the same set of whole number relationships that define the white keys on a piano. For example, one formation near Cheesefoot Head revealed a 4:3 ratio, which corresponds to a perfect fourth in music. Others revealed 5:4, a major third, and 3:2, a perfect fifth. These weren't rough approximations. The ratios repeated across multiple sites, embedded with accuracy that suggested deliberate design. Hawkins went further. While analyzing crop circle patterns, he proved new geometric theorems, relationships between circles and lines that had never been published in mathematical literature. These weren't ideas pulled from textbooks, they emerged directly from the geometry of the formations themselves. To Hawkins, this was a sign of intelligence at work. Whoever or whatever made the designs seemed fluent not only in art but in universal mathematics. The implications were unsettling. Music and geometry are often described as universal languages, understandable across cultures and perhaps even across species. If the circles were encoding these ratios deliberately, they could represent an attempt at communication, a kind of calling card left in wheat and barley. Not everyone was convinced, though. Detractors insisted that such patterns could have easily been produced by hoaxers aided by ropes, several lengths of boards, and surveying equipment. But according to Hawkins, the level of precision and consistency shown in various formations, especially those predating the media frenzy, was difficult to dispute. Math was, he argued, the message. By the 90s, the complexities had multiplied. Simple rings were replaced by star polygons, which in turn gave way to nested hexagons and then by fractal spirals. These formations were related to Fibonacci sequences, prime grids, and even Mobius strips. One design near Stonehenge in 1996 spanned nearly 900 feet long and reproduced the Julia set fractal object that had recently been visualized only with computer algorithms. For mathematicians, this is an astounding leap, a recursive pattern known mainly in theory, flawlessly mapped into a field overnight. The natural question was, did the formation evolve, almost like any language developing from the elementary to an advanced level? The first circles represented basic letters, very easy for anyone to recognize, while the latter circles tended to suggest agglomerations of words, something labeled sophisticated, requiring high levels of mathematical education from natural until decipher. Had there been someone to teach, even if it meant eschewing modulation, without the need for changing codes? Or were mimic circles themselves keeping up with mathematics? This debate had split the whole world. Leaving both sides aside, the number of embedded circles left quite a story to be told. These circles bore elements of diatonic ratios, fractals, and specific constants such as pi and phi in them. They were no ordinary or plain art form, they were acting as indicators of some intention. If in case such geometry was really a language, then the message was a clear one. Somebody wanted our attention, and they were speaking in maths that which defies culture, defies time, and defies the planet itself. But geometry was just the beginning. Soon, researchers discovered biological changes in the plants themselves, evidence that something more than boards and ropes was at work.